Hello friends. So once again I am here with you to have uh, a new course that is inside a DFT, Essential Physical and Chemical Principles. This is also under the banner of CIAN. And I would mention here that just running a SISTA program and some DFT tools, it's not enough to understand that DFT. So if you want to publish some papers, then you must know about the physical and chemical principles related to materials. So this particular course is focused on some essential physical and chemical principles behind material research. So you should know about your instructor. So I am Dr. Mohanel Verma and Professor of Physics. I have 25 years of experience of teaching, research, and academic leadership in material science and that nanotechnology, computational physics. My work is integrated with the DFT. I'm using SISTA and transistor and related tools, pre and post processing tools, and also some experimental tools for material research. And I have established that advanced research facilities, including computational nanomaterials research lab, and supervised more than 15 research scholars across theoretical and experimental domains. My work focuses on structural, electronic, and optical magnetic transport properties, molecular dynamic properties, and for that device relevant simulations. And also, my work is focused on that nanobiomaterials. I collaborate with scientists worldwide and have published more than 125 research articles in peer-reviewed journals, contributed book chapters, and secure funded projects also. And you can go my ResearchGate profile, LinkedIn profile, and other profiles to know about the details of myself. I'm passionate about training the next generation of researchers. I have given training of more than 450 uh, participants, faculties, students worldwide, and created numbers of tutorials and scripts based in Python scripts to help people. And I have developed so many video resources for DFT people. So this course is especially designed for that graduate and postgraduate student as well as PhD scholars, and also some early stage researchers and that industry professionals can also use this, because that physical and chemical principles, these are important to if you want to learn about that DFT in details in depth. So course duration, this is having that four comprehensive module with that 12 lectures and some 12 hours of that hands-on sessions in terms of that reading and that some calculations, etc. Because that there is no programming involved in this one, so that hands-on session at that Sista or that Linux, this is not possible. But some calculation we will perform during this hands-on session, and definitely this is 24 hours course, and that 90 hours per day that will be devoted to that, and also that the 40 to 40 45 to 1 hours a discussion session is always involved uh, in my all courses. Course overview. So this course provides that theoretical backbone of density functional theory, emphasizing on that the fundamental physics and chemistry principles. Unlike courses the focus primarily on software usage, this program uh, deliver deep into the quantum mechanical postulates, electron correlation phenomena, and body physics, and that chemical bonding concepts, because all these things we generally involve during that explanation of our result obtained after sister run. So understanding DFT means understanding the quantum mechanics of electrons in matter, from isolated atoms to complex solids, from chemical bonds to electronic bands. So by the end of this comprehensive programs, the learners will process the theoretical insight to understand why DFT works. Course objective. So the first objective is to master quantum physics fundamentals, and then this understand chemical bonding theory, how that chemical bond happens, and this grasp electron correlation physics, then connect theory to that DFT4 work, and that then this building practical competence, and this provide learners with a theoretical foundation to move definitely into that practical DFT one. So this actually give the details of the development of DFT from beginning of physics and chemistry. Module 1, this will include that 3 lectures as usual. So we will begin with that, the quantum mechanics refresh. Then we will move to that many body problem, that solution of Schrödinger equation for many body, and then that the problems therein. And then some part of statistical physics and quantum ensemble to understand the basic mechanism of many many electron systems and the effect of that temperature and other physical parameters. Module 2, this will give that the chemistry foundation of DFT. So module 2, this keeps that chemistry foundation of DFT, so that atoms and periodicity, chemical bonding and its theory, and then this hybridization, bond formation, because to explain that output file and the explanation of different diagrams, we need to know about the details of chemistry behind that. What is happening when some atom is interacting with other one, and the changes in different plots we can explain. Now module 3, this is focused on that from physics to chemistry to DFT. So this is development of the things to DFT. So that exchange correlation and exchange DFT foundations and quantum framework. So I am going to detail in these things. Then applications and limitations. So practical chemistry with DFT and beyond standard DFT, like what is that DFT+U, DFT+U, BSE, and time dependent DFT. So that the fundamentals, that basics of behind that we were going to give in the conclusion part, and that practical physics with the DFT, that solid band structure and magnetism phenomena. So that this will conclude this course. So so after taking this course, you will be able to understand that the theories of physics and chemistry behind that DFT in deep. So the basic quantum physics, many body problems, other things, and also that conceptual mastery you will have, how this Cohen sum theorem implication is there, and also Cohen sum equation and its derivation and its meaning, exchange correlation function and other things, and also that integration of all these physics and chemistry to that DFT and that practical application. So these are that output you will get. Anyway, so be the part of this course, and definitely I promise that you will enjoy various Eureka moment, and many people are happy with me with similar courses. So I request to be the part of this team. So happy learning. Thank you.